Okay. The way that I'm going to do it is not the only way. I need to emphasize it. It's not the only way. That's based on what comes into my mind when I see the question. Okay? If you did it in a different way, which is mathematically sound, we must both get the same answer in the end. Okay? We must get the same answer in the end. So here, first thing that I'm going to do is to remove the brackets. Okay? I'm going to remove the brackets to make things simpler for me, and I'm going to convert all bases that are not prime to prime bases. Okay? So, the first step is to convert that 9 to a base of 3. Okay? So this becomes 3 squared, all raised to the power of minus 1 times x to the power of minus 2 times y squared, all over. Now, then, but we have got a question. I've converted the 9 to a base of 3. That's the first thing that I did in the numerator. And please do me a favor. Your body language tells me a lot. You see, when I'm standing in front of you like that, I can tell you who is paying attention and who is not. You need to sit straight and show that you've got an interest. You can see the way that I'm standing in front of you. Okay? I don't think you'd have been happy if I was talking like maybe I have no interest, I'm looking outside, maybe I'm drunk or something. No. Okay? So here, you remove the brackets in the denominator. Now, to remove the brackets, you need to know that this minus 3 here is an exponent, which is going to affect every number inside the bracket and every letter inside the bracket. So the exponent of this 3 is the minus 1. So it's a positive 1 times minus 3, you get, I'm going to minimize talking, otherwise I end up making a silly mistake. So that becomes 3 to the power of minus 3. Okay, I've distributed the minus 3 inside the bracket. Then this x here becomes x to the power of minus 3. This is y to the power of minus 1. So minus 1 times minus 3 will give me a positive 3. Okay, so if you did the work, you can give yourself a tick with a pencil. You've got this part. Right. Okay, then the next thing, I'm going to remove the bracket there. So that will be 3 to the power of minus 2 times x to the power of minus 2 times y squared all over 3 to the power of minus 3 times x to the power of minus 3 times y cubed. Yes. Will be 3 to the next. Three power minus 2 not minus 27. It's 1 over 27. Okay? Admit if you made a mistake, admit and correct yourself. That's how you learn. Okay? So when you get here, right, all your bases are what? Are prime. That's very important when you are doing exponents. All your bases must be prime. And I told that the prime bases, the most common ones are 2, then 3, and then you've got 5. Okay? Then the next step, okay, I'm going to use log 2. Because I have a base of 3, a base of 3, base which is x, base which is x, base which is y, base which is y. So I'm going to use log 2. Okay? Remember with log 2, if you are dividing bases that are the same, you subtract the exponents. So this becomes 3 to the power of minus 2. This is a minus 3, so I'll say minus open bracket minus 3. I'm not doing it in my head because I want everyone to see how I'm going to get my answer. I can do that in my head, but I don't want to do that so that you can see how Mrs. Fonda is doing it. Okay? Then I've got x, right? The exponent of the top one is minus 2. The one which is part of the denominator is minus 3. So it will be minus 3. Then I'll put my y. I've got y squared there. This is y cubed. So that will be y to the power of 2 minus 3. If you do it this way, you never go wrong. Okay? You never go wrong. Right? Then You use your knowledge of integers from grade 8 and 9. Minus 2 minus 3 gives you minus 2 plus 3, which is equal to positive 1. So you get 3 to the power of 1. Then x, here, again you get x to the power of 1. Because minus 2 plus 3 gives you positive 1. Then y to the power of minus 1. Okay, because 2 minus 3 is negative 1. Okay, now when you're doing simplification of exponential expressions like this, all your negative exponents must be converted to positive exponents. Using this definition, x to the power of minus n to the power of 1 over x to the n. That's the definition that I'm going to use to convert this y to the power of minus 1 to a positive exponent. So, 3 to the power of 1 is 3 times x, because x to the power of 1 is x, right? That is going to multiply 1 over y to the power of 1. So my final answer will be 3x over 1. Okay? Mark your way. See where you made the mistake. Okay? So that's the first one. Any question? How many of you got that answer? Thank you. If you didn't get it, correct yourself. Right, let me move on to the next question. The next question is that. Okay? Now, the moment you see any base, what must come into your mind is a prime base. Either a 2, a 3, or a 5. Okay? You don't need to get confused. Right? So, here, the 9 is the same as 3 squared. Okay? Raised to the power of 2x times 3 to the power of minus 2. Okay? Then the 81 is equal to 3 to the power of 4, all raised to the power of x minus 1. Okay? Now that I've created brackets, I need to remove those brackets. Okay? So in the numerator, 2 times 2x will give me 4x, so that becomes 3 to the power of 4x times 3 to the power of minus 2 all over. In the denominator, this 4 multiplies the x, also multiplies the minus 1, so I'll end up having 3 to the power of 4x minus 4. Okay? Now, you always get a mark for converting bases to prime bases. There's a mark allocated for that. Converting non-prime bases to prime bases, you get a mark. Now, since the base is a 3 throughout, in the numerator and the denominator, I can just use law 1 and law 2. For the numerator, I'll use law 1. For the denominator, I'll use law 2. So I can write this as 3 to the power of 4x, okay, plus minus 2, okay, plus minus 2, I've used law 1, right? Now I need to use what? Law 2, because this 3 here is part of a denominator, so that will be minus, open bracket. Now, because our exponent is binomial, I have to put it inside brackets. So this becomes 4x minus 4. Now, I also want to remind you that I can simplify this part in my head. But I'm a teacher, I need to show you how I'll get there. I can do that part there in my head. Okay? But I want to show you that I use law 1, then I use law 2 here. This is law 2 that I use there. So a combination of two laws of exponents, law 1 and law 2. Okay, then my final answer here, I'm just going to write it on the next page. Now I can simplify this and write it as 3 to the power of 4x minus 2 minus, now this minus here, it's like there's a 1 there. So it becomes minus 1 times 4x. So you end up having minus 4x, then minus 1 times minus 4 gives you a positive 4. Then, if you look at the exponents, this is 4x, it cancels with that minus 4x. Okay? You cancel out. So your final answer will be 3 to the power of minus 2 plus 4, which will give you 3 squared, and the final answer will be 9. Yes?
So I don't understand how 4x can be negative
4x minus 4x. Okay, what is 4 minus 4? Forget about the letter. If the letter is the same and the exponent of that letter is the same, you just consider the coefficients. So 4 minus 4 is 0. 4x minus 4x is 0. Yes? Okay, how many of you got the 9 for this? Thank you. Okay. Any question? Let's move on to the next one. Alright. This one, you have to use this definition to do it. Make this definition x to the power of minus n is equal to 1 divided by x to the power of n. Okay? Together with your knowledge of fractions, okay, you need that to do the question. So, firstly, I'm going to convert all negative exponents to positive exponents. That's the first thing that I'm going to do. Okay? So, my first step is like equals 1 over a squared. Okay? Plus 1 over a. Now, a to the power of 0 is 1, so I'm going to write that is 1 over 1. Alright? Are you following? Then all over a. Now here, my main division line is this one here. My numerator is a sum of fractions. Yes. That is a to the power of 0. 1, right? Do you know that any integer can be written as a common fraction with a denominator of 1? The reason why I'm doing that is because this is a fraction, that's a fraction. So I can put plus 1 here, but because I want to... Which area do you want? Yeah, it's here. Oh. Yes. So we have fractions, a sum of fractions with the numerator, and we have got a denominator, which is the letter. Okay? Why did I write 1 over 1? Is because I'm dealing with fractions. 1, 2 are fractions. So it don't make sense for me to write a whole number here. Do you understand that? Because I'm going to need to find an LCD. Okay? I'm going to need to find what? LCD here. I need to find an LCD. That's why I wrote the 1, which I get from a to the power of is 1 over 1. In any case, you should all know in this grade that 1 is the same as 1 over 1. It's the same thing. Yes? No, it's not correct for this question. You can't do that for this question. You can't. You will be violating rules of mathematics to do that. Okay? You have to simplify them as part of the numerator. Remember, we have addition here. If there was multiplication, that's when you can do it. There is addition, don't forget it. There is addition. Okay, so the next thing now is to find the LCD of the numerator. What's the LCD or the highest common factor of a squared, a, and 1? It's a squared. It's the one with the largest exponent. Okay? Your grade 8, 9, and 10 teacher must have taught you that. Okay? If you have got letters that are the same, if you want to find the LCD, it's going to be the one with the largest exponent. Okay? So, because a squared is the LCD, it means I'll rewrite the first term as it is. I'll rewrite the first term as it is, so it's 1 over a squared plus Now I need to make this a equal to a squared. So I will multiply it by what? By a, and I will multiply its numerator by what? By a. Remember, whatever you do to the denominator, you also do to the what? Numerator. That's a basic rule of maths when you are dealing with fractions. So this becomes a, because 1 times a gives me a over a squared. I have incorporated the concept of the LCD. Okay? Plus, how can I convert this 1 here to a squared? I'll multiply it by a squared. If I multiply this 1, which is the denominator, by a squared, I also have to multiply the numerator by what? A squared. So I'll get a squared over a squared, all over a. Alright? Now that I've got a common denominator, okay, which is a squared, I can now rewrite my numerator in such a way that the numerators have the same denominator. So my next step is to say 1 plus a squared all over a squared all over a. Don't forget, your main division line is this one here. This is the main division line. So when I write it here, my main division line is going to be this one. Okay? I've written this numerator here, which has got a denominator which is equal to a squared throughout, like that. You should know that this is the same as this. The denominator is now the same. Are you following? Yes. Then, my next step now is to introduce the division sign that you were taught in lower grades. Okay? I'm going to replace this division line by a division sign to make things simpler. Okay? So from here, I'll have 1 plus a plus a squared all over. Now check this. The denominator here of that numerator is a squared. Okay, divided by. I have converted this division line here, which is my main division line. I have converted it to a division sign. The denominator of the whole fraction is a. Okay, I can put a over 1 here. Okay, then I need to convert that division sign to what? Multiplication. Then this becomes, okay, allow me to rearrange these three terms starting with a squared. So I can write it as a squared plus a plus 1 all over a squared times 1 over a. Okay, I converted division to multiplication, so I inverted those two. You did that last year and in grade 9. Okay, then all I have to do now is multiply numerator and numerator, denominator and what? Denominator. So that will become a squared plus a plus 1 over a cubed. Alright? Now, the numerator is for what is called the perfect square trinomial. I'm not going to take, it's not a perfect square trinomial because there is no 2 there. It cannot be factorized. So this will be my final answer. Okay, that will be my final answer. There is no need to try to rewrite each term in the numerator under the same denominator. There's no need. You can leave it like this. Okay. Any question? Any question?